Okay, so now let's go ahead and do number 7 and number 8. So what we're seeing here is we're seeing a graph, and it's through JUMP, which is a statistical software. And if I hover over it, I can see that this is number of calories for 65 different candy bars. So remember, our sample size is 65. That's going to become important in just a minute. So if I hover over each bar, I can see there's 8 candy bars that have 150 to 200 calories. Most candy bars, there are 29 that have between 200 and 250 calories. And then we even have a candy bar that has 450 to 500 calories. All right, so the first question asks, what proportion of candy bars have more than 400 calories per serving? So remember, proportion means that I need to take the part I'm looking at over the whole sample, which remember was 65. So if I hover over here, I find 4 and then 1. So I'm going to do this. I'm going to show you my calculator. Let's do clear. I'm going to do 5 divided by 65. If I do that, I get 0.76, but it wants me to round up. So I'm going to do 0.08. Okay. So then the next is fewer than 30. So here's 30, and I want to get everything below it. So I'm going to do this as I go. I've got 19 plus 29. Okay. Oops. And then I'm going to look at the last one, plus 8 and 1. So I'm going to put those both in. 8 plus 1. So I hit enter, which is 57 candy bars. But remember, I want the proportion. So divided by 65 equals 0.876. But remember, I need to round up because this 7 is right next to a 6. So I get 0.88. All right. What's the last question say? What is the best estimate for the percentage of candy between 175 and 250 calories? All right. So I want to know here to, what did it say? 250. Okay. So I'm looking at this huge bar and part of this bar. So let's see. This was 29. So I put 29 down, and then what is it asking me? It's asking me what's the best percentage. Okay. So I know right here, if you see here, it says the share is 45%. So I'm going to write that down too. So I know the number is 29 and the percentage is 45. Okay. So here, I don't want this whole bar. I really want the middle over. So the easiest thing for me to do is divide the number divided by 2 and split it in half. So 8 divided by 2 gives me 4. Or I could do the share, which is 12%, and divide that by 2. Okay. So I'm going to do it 2 ways. So let's do it with the numbers. So I'm going to do 29 plus 8 divided by 2. Okay, and that gives me 33, and then I'm going to divide by 65 again. And that gives me roughly 0.51%. And we can do it the other way too. I can take the 45, the percentage, plus 12 divided by 2, divide it, 51, and I'm going to do that. Remember, I don't need to do anything else because it's already as a percentage, and that's what it was looking for. So the 29 plus 8 divided by 2 is the actual number of candy bars. The 45 plus 12 divided by 2 is the percentage. So I go down here and put 51. All right, last question asks, what is the best way to describe this graph? All right, so I have a lot of data here between 300 and below, but then I have data up here. So think of this graph as skewed to the right, or positively skewed, because with skewed to the right, most of the data is on the left-hand side, and there's a little bit of data on the right-hand side. So this is, for this one, skewed to the right. All right, so let's talk about number 8. So number 8, you're the manager of a coffee shop and you collect data regarding wait times for customers from the time they enter the shop until they pick up their order. And a lot of places do this. So what type of distribution do you think would be most desirable for wait times? Skewed right, skewed left, mound shape, or symmetric? Well, let's go back up here and look. Remember skewed right. So that means when you're skewed right, a lot of your data is to the left and then you have some to the right. So think about it. If we did this in time, I would want most of my times to be into the left part of the graph because I want them to be a short wait time with only a few long times. I don't want it to be symmetric and I don't want it to be left skewed because if it's left skewed, that means there's very little short waiting times and a lot of long. So the most desirable would be the right skewed because it'd mean there's be a lot of short waiting times and only a few long waiting times. Okay, so what if it was binomial? What might be some explanations? So remember, binomial is when you have two distinct events. So you're going to have two very different mounds, or we say distributions. So there's something dividing them in the middle. So a binomial would look like maybe if you have really busy times or really slow times, like there's no in between, like you're getting slammed and then nothing is really happening. So this is the answer. A binomial distribution for waiting times might exist, if orders are filled at different rates during busy and slow periods. And that happens a lot. You can see it in fast food where you have a lot of people during the lunch rush and the dinner rush, but not a lot of people in the other times.